Start with the greatest name of Allah, the most kind and most. Assalamualaikum. This is Yasir Ali from the Department of Computer Science, page 2K2. In this video, I am going to present the fundamental presentation of numerical analysis. So here are the topics that I will cover in this video. Topic number 1, introduction of numerical analysis. Topic number 2, area of study. Advantage and disadvantage of numerical analysis, Newton-Raphson method, working rules of and C program of Raphson method, Pecan method and its working rule and C program. So before we go further, let's discuss what the numerical analysis is. The numerical analysis is the study of algorithms that use numerical approximation as opposed to symbolic manipulations for the problems of mathematical analysis as distinguished from discrete mathematics. Numerical analysis naturally finds application in all fields of engineering and physical science. But in 21st century, also the life sciences, social sciences, medicine, business, and even the arts have adopted elements of scientific computation. The growth in computing power has revolutionized the use of realistic mathematical models in science and engineering. The subtle numerical analysis is required to implement the detailed model of the world. For example, ordinary differential equations paper in celestial machines predicting the motion of planets, stars, and galaxies. Numerical linear algebra is important for data analysis. Stochastic differential equations and Markov chains are essential in simulating living cells for medicine and biology. So here the areas of study where the numerical analysis is used. The field of numerical analysis includes many subdisciplines. Some of major ones are computing values of functions. One of the simplest problems is the evolution of a function at a given point. The most straightforward approach of just plugging in the number in the formula is sometimes not very efficient. For polynomials, a better approach is using the Holland scheme since it reduces the necessary number of multiplications and additions. Generally, it is important to estimate and control round of errors arising from the use of floating point arithmetic. Area number 2, interpolation, extrapolation, and regressions. Interpolation. So interpolation solves the following problems. Given the value of some unknown function at a number of points, what value does that function have at same other point between the given points? Extrapolation is very similar to interpolation, except that now the value of unknown function at a point which is outside the given points must be found. Regressions. So regression is also similar, but it takes into account that the data is imprecise given some points and a measurement of value of some function at these points with an error, the unknown functions can be found. The least square method is one way to achieve this. So these are all also the areas of study: solving equations and system equations, solving eigenvalue or singular values problems, optimizations, evaluating integrals, differential equations, etc. So what are the advantages to use numerical analysis? So numerical analysis are mathematical ways to solve certain problems whether the equations are linear or non-linear. Efficient and robust numerical methods are required to solve the system of algebraic equations. Number two, analytical solutions are exact solutions based on mathematical principles. Advantage number three, however, the governing partial equations, differential equations of fluid flow are complex and cannot be solved by analytical means. The partial differential equations are therefore converted into a system of algebraic equations that are subsequently solved through numerical methods to provide approximate solutions to the governing equations. Advantage number four. Although we are rarely reach an exact answer, we can get very close to the exact answer much quicker than solve analytically. So their further advantages are they are often easy to use, they can produce results quickly, they can solve equations whereas an analytical solution is impossible. So we know that everything has advantage as well as disadvantage. So what are the disadvantages of numerical analysis? So let's see. They are not as elegant as analytical solutions. They do not provide any insight into generalizations, and exact value may not be clear. Difficulties representing irregular boundaries, not optimized for unstructured meshes. Momentum, energy, and mass are not conserved, not well suited for turbulent flow, slow for large problems. So, topic number two, there is Newton-Raphson method. So, the Newton-Raphson method, also known as the Newton's method, is a way to quickly find a good approximation for the root of real valued functions f of x equal to 0, f of x equal to 0. It used the idea that the continuous and differentiable function can be approximated by a straight line tangent to it. So, what are the working rules of Newton-Raphson method? Let us discuss. So, rule number one, that is, let f of x equal to 0 be given the equations. Rule number two, find initial root of x0 such that f of x0 not 0, so x0 is near to root. Number three, find f of x and f of x 0. Rule number four, find first approximate root using Newton method. So here's the method as you can see. So rule number fifth, that is find second approximate root and then calculate, repeat steps until the required accuracy of root found. So this is the C language program of Newton-Raphson method. In its left side, so left and right side is a part of a program. It is a one program. So starting with the header files, which include stdoh, include conioh, and we have used include math header for using math formulas. Define E0.001. It is the least root that we want in this program. So we have defined functions, that is f of x multiply x minus 3x plus 1. So we have taken x0, x1, f0, f1, d, f0. We have taken 5 variables of float data type, and we have taken also an integer variable that is hard. So firstly we write a message that enter the value of x, in which we give the value of x0. So then it goes to the loop, in which we have written that f0 equal to f of x0. So similarly df0 equal to df into x0, x1 minus x0 minus f0 divided df0. So as you can see, this is the whole program of how to solve a Robson method. So there's another method, that is secant method. So what is the secant method? Secant method is a root finding algorithm that uses a succession of roots of secant lines to better approximate a root of a function. The secant method can thought of as finite difference approximation of Newton's method. So these are the working rules of secant method. Rule number 1, let f of x equal to 0 be the given equations. So rule number 2, find x0 and x1 such that f of x less than 0 and f of x1 greater than 0, or f of x 0 into f of x1 less than 0. Rule number 3, find first approximate root using secant method. So rule number 4, find f of x2, in which find second approximate root of x3. Rule number 50, find third approximate of root x4. So these steps repeats until we get the approximate root. So here the program of secant law, and so this is the program of secant law actually, in which we have taken for 5 variable of float as well as an integer one variable, in which we get the value of x0 and as well as x1. In right side, a loop is used in this program, that is to iterate iterations in the program until we get the approximate root. So thank you.